This is a tutorial on the vertex and intercept forms of a quadratic equation. First thing we're going to talk about is the vertex form of a quadratic equation. And the vertex form looks a lot like this. We have y is equal to a times x minus h squared plus k. Now a, h, and k are just numbers or constants, so our variable then would be x. Now this is called vertex form because if you remember, the graph of a quadratic equation looks like a parabola that opens either upward or downward. So if the graph of a quadratic equation looks something like this, then at this low point of our graph, we have our vertex. This is called the vertex form because our vertex is just the point HK. This is our x-coordinate of our vertex, and this is our y-coordinate of our vertex. That also means that our axis of symmetry, which is an axis that passes through our vertex, and that means that our parabola is symmetrical on either side of that axis. Our axis of symmetry just has the equation x is equal to h. Now the last thing we have to recognize in this form is that if a is positive, that means our parabola will open upward. And if a is negative, that means our parabola will open downward. So let's see how we can use that information to graph our quadratic equation. Here we have y is equal to 2 times x minus 1 squared plus 3. Now again, we know this is a quadratic equation because of this squared term. And this tells us that our vertex is at the point 1, 3. Because 1 would be our h and 3 would be our k. That also tells us that the axis of symmetry is the equation x is equal to 1. So if we graph that, our vertex is at 1, 3, and 1, 3 is right here. And then our axis of symmetry is the line x is equal to 1. So it's a vertical line that passes through the coordinate x equals 1. So it'll look something like this. And that means that our graph will be symmetrical on either side of this line. Well, we have our vertex. And if we look at our a term is 2, and 2 is positive. So if this is positive, that means our graph is going to open upward. So let's find another point on this line. Let's pick x is equal to 0, and we'll plug it into this equation and solve for y, and get another point. So if we do that, we get y is equal to 2 times 0 minus 1 squared plus 3. Well, 0 minus 1 is just a negative 1, so we call that y is equal to 2 times negative 1 squared plus 3. Negative 1 squared is just 1, so we have 2 times 1 and then plus 3. 2 times 1 is 2, and then plus 3 would be 5. So we have the point then 0, 5. Well, if we plot 0, 5, that's right here. Now remember that this graph is symmetrical across our axis of symmetry. So the point 0, 5 is 1 unit away from our axis of symmetry. So if we go 1 unit to the right of our axis of symmetry, then we'll get the point 2, 5. And since this is symmetrical, that means 2, 5 is also a solution to our quadratic equation. So now that we have all these points, we can graph our parabola, and it'll look something like this. Now let's look at the equation y is equal to 2x squared. This is very similar to our first equation, y is equal to 2 times x minus 1 squared plus 3. except we don't have our vertex information in here. So let's just plot a couple points. We'll pick x is equal to 0. So if we pick x is equal to 0 and we plug that in, we get y is equal to 2 times 0 squared. And 0 squared is 0 and times 2, so that would be y is equal to 0. So we have the point 0, 0. Let's pick a couple more. Let's plug in x is equal to 1. If we plug in x is equal to 1, we'll get 2 times 1 squared. 1 squared is 1, and then multiply it by 2, and we get 2. So if y is equal to 2, then we have the point 1, 2. And let's plug in negative 1. If we plug in negative 1, we get y is equal to 2 times negative 1 squared. Negative 1 squared is just 1, and multiply it by 2, and we get 2 again. So we have the point negative 1, 2. So let's plot these. 0, 0 is right there. 1, 2 is right there. And negative 1, 2 is right about there. So with these points, we can graph our quadratic, and it's going to look something like that. Now, what's important to notice here is that these two equations have exactly the same graph, except that our first equation, y is equal to 2 times x minus 1 squared plus 3, has just been moved up and to the right. In fact, it's been moved to the right 1 and then up 3. Well, that's our vertex, 1 and 3. So these are the same equation, just when we add this vertex information, we're just moving our graph to the right and up.